Welcome to today's exam riddle. As starting materials, we have this Aryne. Of course, this is a reactive intermediate, has been generated by the typical procedures of some elimination reactions. Then we have this five-membered ring with a ketone and an ester functionality. It's a beta keto ester. And as the product, we have this annihilated ring system, six-membered, a five-membered ring, functionalized again with a ketone and an ester. The question now is, what is an appropriate mechanism which can explain this transformation? Please try to solve that riddle by yourself first before listening to the explanation presented. So, in the start, we should compare the product with the starting materials. It is clear that these five carbons of the five-membered ring end up here, 1, 2, 3, 4, 5. Or maybe sometimes it's better to write that down. 1, 2, 3, 4, 5. And now we clearly see that the CC bond between position 1 and position 5 has been broken. Well, it's not easy to break a CC bond. There has to be this reactive intermediate involved, and now we should remember that this double bond is a very weak double bond because it results from an overlap of two sp2 hybridized orbitals. They a bit point away from each other, and then the overlap integral is rather small. Therefore, we can also draw this structure as a diradical, and it has, well, features of a diradical. It can react like a diradical. But even a diradical not directly reacts with such a CC single bond. Here, a tautomerization is possible. It's a keto-enol tautomerization. With the double bond here. Alternatively, this molecule A could be deprotonated by a base minus H+, then we would be on the stage of an enolate, also with double bond character here. Either here or there, the diradical can react. Maybe a concerted process. And then a four-membered ring will be formed. So connect this center with that one, this center with that one. Four-membered ring. Here we have the OH group. On the other side, the ester functionality. So, and how can now this bond between position 1 and position 5 break? Well, we have a donator molecule here, mesomerically this oxygen can donate electron density although electronically it is a highly electronegative element. Well, it is a donator-acceptor system. And when the CC bond breaks, we have here the ester, which can mesomerically stabilize this anionic charge, and on the other hand, we have this mesomerically stabilized cation, mesomerically stabilized both by the free electron pair at the oxygen, and it is also stabilized as a cation here in benzylic position. Well, one mesomeric structure here is, for instance, this one. It's only one of the mesomeric structures. It is one where the aromatic character is lost, of course. And now deprotonating here, protonating there will lead to this target molecule. Thanks for listening.